Hi everyone. This is a quick overview of the software stuff that I have. I'm going to share my screen now. Um, so as detailed here, where is it? As detailed here, I've got two bits of software, right? There's a tracking bit of software, which is good if you want orientations and if the B is quite small. I've got some details about where it's not an amazing piece of software, but if other stuff doesn't work, this does work. It involves quite a lot of clicking, but it means you probably adjust about a third of the frames rather than all the frames. So if you're going through clicking all the frames, then use this. It takes a little bit of getting used to. So if you've only got a couple of videos to do, it might not be worth it, but it's not too difficult. I'll put up more if people want to use this, get in touch and I'll put up more instruction videos, right? The more interesting one is the plotting and analysis stuff. This is in a function called PlotFlightsAndRates. And basically what it does, it allows you to step through individual trajectories, look at different variables that are in there, and then accumulate data across the flights. I'll kind of show you how this works. There's some instructions of it here. There's basically quite a lot of different instructions in this. So when I run it, right, it comes up initially with lots of different options. So first of all, you select which flights you want to look at. So this goes through all the folders, the files that are in a folder that match this all.map thing. And if you want to use it, I've got functions that will transform your data into this format. Anyway, it looks for all these ones. Normally you select them all by pressing return, then asks you which bit of the flight you want to look at. So you look at flight in portioned to different distances from the origin, which is normally the nest for me, but can be a different point for you, or at different time sections through the flight. Again, I can just pick the whole flight. There's then some stuff about the compass, how you set the compass, which is what angles are defined by, but there's more detailed instructions of that right at the end of the thing. That's a bit complicated. For now, you just press return. You can add a fictive landmark. The reason for this, again, just press return for now. And now it's showing flight direction of the nest. Again, just press return for now. It's more, these are more advanced options, if you like. I mean, advanced is a relative term. Again, you can change the times between the video. Again, don't worry about it for now, press no. The data, the angular data is shown so that it doesn't have a flip in it, right? So that if it goes through 360 degrees, it doesn't flip back. You can change this option. And then it shows all the different things that we might want to see, right? It's got different variables that you can look at. So for instance, I might want to look at the body angle and the flight direction of the bee. Maybe I'll also look at the distance of the nest, right? Okay, distance of the nest. I say yes, and then it defaults to plotting these ones over time, which is quite useful. So we plot them over time, and then what it does is I'm going to do no smoothing. Again, that's kind of an advanced option. Then it allows you to look at what variables want to filter. So basically, the main point of this this thing is that you can look at different variables. You can also pick out certain elements of the variables that you want to look at. So for us, give an example, right? For us, it was important. We thought points where the bee was flying forwards, like relative to its movement direction, were important. So I want to look at how different variables vary when the bee is doing that and when it's not doing that. So to do this, what I do is I filter here. I want to look at, so psi is the direction of the flight, the bee's facing direction relative to the direction of moving, which is psi. So when this is 0 or close to 0, it's flying, it's facing the direction that it's moving. So if I filter for points where the bee is where psi, which is the movement direction relative to its facing direction, is between 0 and 10 degrees. Normally that's what one looks at. I can filter for that, and it's going to show me these points separately, as we'll see now. So here, this is the flight. The bits that are highlighted in red here are points where it's flying directly. You can see it's points where it's flying in the direction that it's facing, right? So why is this important? So we can see that certain these points, we could argue, oh, look, this one's right on the edge, right? It's on the edge of a turn. That might be useful. There's also when it's kind of facing this one of the landmarks, and this one also is when it's facing a landmark. So this might come out to be interesting, right? Again, these points are highlighted. This is it's the body axis changes. As I said, this is not flipped. So once it goes from beneath 300 degrees, it changes. This is the flight direction. And this is how far it is away from the nest position, right? So we can see these different variables, and highlighted in red are the different points here. Now, in this panel are the distributions of these data. So these are the distributions of the red data. These are going to be really spiky for individual flights. And then the black data is the distribution of the rest. This is not really important for now, but it's more important when it's accumulated across different flights. If I then press return, it goes to the next flight, much longer flights. We've got more of this data where it's flying straight at these various points. So we've got all this interesting data here. We can look at these different flights. And then once it gets to the end, it accumulates the data that you've looked for across the different flights. So now these are distributions summed across the flights, right? So this is the body angle across the two different flights. And oh, look, where psi was 0, it's got a really sharp peak in the body angle, right? Vaguely, it's probably not very significant over two different flights, but it allows you to look at this data in different ways. It also allows you to correlate the data over time and over different things. So it then asks you, you can then, once you've got to the end, you can actually plot any of the data again against any of the other data. So maybe I want to say, okay, I want to look at, for instance, the distance to the nest, which is variable 4, and I want to look at it instead of its time. I want to look at its normalized time. Where normalized time is between 0 and 1. So I take the first bit, because sometimes flights are different lengths or bees are faster, so it's better to look at things of normalized time. And this is variable 8. And normally just press return for this and press return for this. And I'll go into those different things at a certain point. You press return and it shows you this. So this then shows me this distribution, right? This shows me the distance to the nest for all of the flight. And it shows me the distribution where psi is between 0 and 10. It shows me it's not right at the beginning. It also, I think in 11, this shows me how this distance to the nest increases as normalized time. And as you can see, generally the distance to the nest increases as we go along in time. Not so amazing at this point, but just to show you roughly what this function does. Anyway, I can talk in much more detail about it with people who are interested, but that's a rough overview.